Another example, the lattice energy of sodium bromide and hydration energy are 733 kilojoules and negative 741 kilojoules respectively. A. Calculate the heat of solution of sodium bromide, of solid sodium bromide. Right? So the answer is simple. We know that enthalpy change of solution equal to enthalpy change of LAT plus enthalpy change of Hyd. Remember, hydration energy is always exothermic, negative. Lattice energy is bond breaking, which is positive. So we have this, which is 733 plus into minus 741. Our answer is going to be 733 minus 741, and the overall is negative 8 kilojoules per mole. Now the overall reaction is exothermic, and we know how an exothermic energy levels looks like. So let us, the next question B is that draw the energy level diagram for the dissolving of sodium bromide. So this is very important. It is going to help us to know, we have already now known that the overall dissolving of sodium bromide in water, the overall energy change is negative 8. So the reaction is exothermic. The overall reaction is exothermic. So let us see now how you are going to draw the energy level diagram. So draw your y-axis. I've drawn my y-axis. Let me draw my x-axis. There is this. Since the final reaction is exothermic, our reactants must start in the middle here. Our reactants must start in the middle here. Right? So our reactant is sodium bromide added to water. Remember, that is the reaction, because we are dissolving ionic compound in water. That is the concern. That is what we are doing. So what will happen? Stage 1, the sodium bromide will break, the bonds will be broken, forming sodium ions in gaseous form and bromide ions in gaseous form. So that one is endothermic and it has to go up. So this one will go up. This one will form sodium ion in gaseous form plus a bromide ion in gaseous form. But this one, these ions are still in water, therefore plus water. Right? So if they are still in water, what do they form? They form a solution in aqueous state. Sodium bromide plus water. What are you forming? You are now immersing these ions in water and you are forming a solution. Therefore, heat of solution must come down. Therefore, even before we bring it down, we can draw this one. You can draw this one. So sodium bromide plus water, we form a solution. This one, so we are going to form sodium ions aqueous. That is the final product, plus bromide ions aqueous. So sodium ions in gaseous form plus bromide ions in gaseous form plus water, what did they form? They directly form, this one is in aqueous, right? So that's why this one comes like this. Now we have this one, but from the equation we have hydration energy. Hydration energy is from here up to here, which is negative 741 kilojoules per mole. We have lattice energy. Lattice energy is the energy of breaking the bond to form a sodium ion in gaseous form. So that one is lattice, which is 733. So we can calculate now this heat of solution. We can calculate using this one. And this is how, so you write this one, a reaction, but here make sure you write energy. And this is now the energy level diagram for dissolving sodium bromide in water. Have you seen the difference between endothermic and exothermic? Now this is how exothermic looks like. But now we have the heat of solution, which was negative 80 kilojoules per mole. Use the following information to answer the questions below. Enthalpy change lattice of magnesium chloride, LAT, is negative 2489 kilojoules per mole. Hydration energy for magnesium 2 positive is negative 1891. Hydration energy of chloride ions is negative 384 kilojoules per mole. The question is, calculate the heat of solution of magnesium chloride. Draw an energy level diagram of the dissolving of magnesium chloride. Is the dissolving of magnesium chloride an exothermic or an endothermic process? Give a reason for your answer. So this is the final question I want us to answer, and by doing this, I think you must have seen how these things are done. So the lattice of magnesium chloride is negative. So first let us calculate the total hydration energy. So magnesium 2 positive alone has negative 1891 kilojoules per mole. Chloride ion, one chloride ion is negative 384 kilojoules per mole. But remember, magnesium chloride is written magnesium chloride. So the chlorides are the two of them. And this is the enthalpy change, or the enthalpy of hydration of one chloride ion. Therefore, we multiply here times 2 to get the total. This one will be 8, 16, 7, negative 768. So for us to get the total, the hydration energy for magnesium chloride, we add this and this. That is negative 1891 plus minus 768. We get the total for hydration. So using your calculator, this one will give us negative 2659 kilojoules per mole. So that is the hydration energy. But we know heat of solution. We know that heat of solution, enthalpy change of heat of solution equal to lattice, LAT, plus enthalpy change of hydration. So look at this one. We were given that the enthalpy change of lattice of magnesium chloride is negative 2489. So we are dissolving magnesium chloride in water. So this negative has no effect here, because the reaction of breaking magnesium chloride into magnesium ions in gaseous form and the chloride ions in gaseous form is endothermic, because we are breaking, and if it is endothermic, this value must be positive. So this negative sign should not scare you. So you assume that it is not there, because dissolving magnesium chloride in water, the first stage we have said, magnesium breaks, magnesium chloride, the bonds are broken, and the bond breaking is endothermic. Therefore, this value is positive. So we put here 2 a 248 9, which is lattice, plus into hydration negative 26 59.